We're gonna we're gonna go over some of the basics of composting. This is very, very basic. So I will be around if there's any other questions. The other thing is Alberta Agriculture has a manure composting manual. It's available online. I have some here. You can pick some up as well. It's on Rope in the Web. So this goes into detail, a lot more detail than what we're going to talk about here. Now I wanted to start off, you're probably looking here and seeing stockpiling. Why are we talking benefits of composting versus stockpiling? Well, we have a lot of producers call and say, oh, I have some compost. It'd be great for your garden. It's been there 5-10 years. It's got to be nice and composted. Well, it is decomposed manure. You do have a lot of benefits with that, but it's still manure and it's not compost. So when you're listening to this, you have to remember that maybe composting isn't for you, but you have to think about what kind of a product do you want in the end. Therefore, that's going to tell you what type of process you need to go through. So we'll go through the differences between composting and stockpiling, and in that it'll turn into the benefits of composting. So in stockpiled manure, any pathogens or weed seeds that are in there, they're not going to go anywhere. In fact, those pathogens that are there, that stockpiled manure actually provides a breeding ground for them. It's the same with flies. You've provided a really nice breeding ground for flies, and there will be flies there all the time. With composting, if you manage your compost pile, the viability of your weed seeds and your pathogens are actually destroyed, and you do reduce through the process that fly breeding ground so that it's eliminated. Now, just because you say you're composting and you pile it all up, you don't magically get rid of any odor or any flies that are there. You will have flies for the first while, and there will be an odor those first couple times you turn it. After that, with the feedlot manure, we really start to smell a lot of silage when we're turning it. And after that, then you start to get into a nice soil smell when you turn it. So also with composting is you have a reduced mass and volume, so you have an easier product to work with, a nicer product to apply to the field, and your neighbors probably don't mind it nearly as much when you're hauling it out and applying it beside their acreage there. So you have improved transportability of it. You can haul it farther because it's not as heavy. And you can fit more on the truck, of course. So you have a soil conditioner, you have a saleable product. So again, you need to think about what you want to do with this. And this product improves your soil structure. And with that, there's a lot of benefits that we can go into, but most of those are covered in the booklet. So these are things like it increases your root penetration because it improves the structure of that soil. It increases the water retention. And then, of course, it has all the nutrients and the micronutrients that are present in it that are beneficial for the soil as well. With that, I also want to say that it brings with it a whole host of microbes that are beneficial to that soil, and it has been documented that a lot of them will increase your natural plant disease suppression abilities. So these are some benefits that you're going to have with this material that you wouldn't get from an inorganic fertilizer. So with that, we'll move into, okay, here's this great product now, how do I produce this? So it's quite easy. You take your manure in your bedding and you pile it up. So the structure you're looking for is about 4 meters wide at the base and about 2 meters high, and just kind of how it comes off the truck, sort of trapezoidal in shape, and build it in length. The key is you don't want it too big because then you can't monitor all of it, and you don't want it too small because then you're not going to get the heat that you need. Now, the microbes that are present in there that will do the composting for you, they need 3 things. They need food, and you've given them that by the manure and the straw. They need oxygen, because like us, they need to breathe to survive. And they need moisture. They need moisture because this helps them move through the windrow and decompose everything that's in there. It helps with their metabolic processes. And it also, if you've ever been to a wedding on a really hot Saturday in a non-air conditioned hall, and everybody's in there and it gets hotter and hotter and hotter, well, that's what these microbes are like. If they're thriving, they're generating heat, and it can get too hot for them. So those are the 3 things that they need from you. So with that, there's 3 things that you need to do. You need to monitor the temperature of that windrow. You need to probably add some moisture to it, especially if the weather's going to be like this. And you'll need to turn that material. So now we'll go through. So now we're in here in this main process here. So we'll talk about those 3 things that you need to do, and we'll relate them back to what the microbes need. And with that, we'll use the first factor here, and that's temperature. Temperature is a great indicator of what's happening in that windrow, because obviously you can't look in and see these little microbes working. So when you pile up that manure and your straw, what you should have is the temperature rise and increase to about 50 to 60 degrees Celsius. As long as it's between 50 and 60 degrees Celsius, you know that those microbes are happy. They have the oxygen that they need, they obviously have the food that they need, and they have the moisture they require. And what you might see is that temperature then shift up and you're over 60 degrees Celsius. They're still there, but they're probably not as happy, probably the same as you, at this wedding dance. So what you can do is you think about it, okay, they have oxygen because they're still surviving, but they're hot. So they probably can't control their own heat, and they do this through moisture. So it means I don't have enough moisture in there. So what you'll want to do is come in and turn that material, because then you immediately satisfy their need and you reduce their heat. And then you want to add some moisture to it so that they can then control their own heat loss again. And now they're back to, okay, I'm happy again, I'm able to control my heat and I'm still eating and the rest of it. This will happen for a while, and you need to keep monitoring that temperature and keep it there. You might see it drop down below 50. And that means that, okay, they're still there, but they're not really all that happy either. And what this probably means is that, so we've given them the food and we've dealt with the moisture. So what are they missing now? It's the third thing, oxygen. So you'll have to think about, why are they missing the oxygen? And it might be, if you're composting in pen, it might be compacted. If the cattle are walking over top of it, so you'll need to turn it. You might want to remove those cattle during the process. Natural compaction occurs as well, so you'd want to go in and turn this material, give them back the oxygen they need. The other thing that might happen is, we talked, a benefit of this is it has a big water retention capacity. Well, when it rains, it absorbs all this moisture, and when it does that, it displaces oxygen in order to hold that moisture. So you might have too high of a moisture content, and you can decide what you want to do. You can, pardon me, you can turn the material and you can try to dry it out. You can add something that's drier. You can add more straw or sawdust or something to it to try to absorb some of the moisture, reduce the overall moisture content. So you need to decide what you need to do, but you need to get it back so those microbes are happy again and they're living in the 50 to 60. Am I moving around too much for you? No? Good. 50 to 60 degrees Celsius zone. Now you might see that you go out and you put your temperature probe in, and my temperature's down here, but I know I don't have too much moisture, and it's nice and light and fluffy. That girl, she doesn't know what she's talking about. Well, what probably happened if you were only periodically measuring it, you missed when the temperature was really high. And what happens after everybody goes home from the wedding? The room cools down, right? So all these microbes that were in there, they were hot, you didn't give them what they needed, and they died. So the pile cooled down and moved over here. So your problem occurred up over here, so you need to add some moisture to that material. And that will move them back into the happy zone. You might also find that the temperature is down here, but you did control it. You know you didn't miss this high temperature. And if you look back and it's been 4, 6, 8 weeks, what's probably happening is you're moving into a natural curing phase, and this is a completely different set of microbes. That whole food structure has changed, and it's now being colonized with different microbes, and they want it cooler, so you just leave it and you let it go into a natural curing phase, 2 to 3 months, and then you land apply it when you're ready. So that's how you can use the temperature to tell you what's happening in there. And the other reason that we turn windrows is when you have it sitting there, we use a nice long probe to reach in to measure the temperature. So this is a meter into the material. Well, this material that's up here on here, it's probably not at 50 degrees Celsius unless it's really hot out. So when you turn it, you're moving this outside material to the inside. And so you're giving all the material in there a chance to be at these high temperatures so that you know that you have destroyed the viability of those weed seeds and those pathogens, and you have a homogeneous product. Now, the moisture content, we've talked about that and how to add the moisture. You want to keep the moisture content between 50 and 60 degrees or percent. Here in the summertime, you can go higher onto the 60 and then, let it drop down to the 50% before you need to add it again. Now at work, when we have some trials, I go and I take some samples and I make nice little manure pies and I put them in the oven and I dry them. And now they don't let me do that in the office anymore. They don't even let me do that in the shop. They put me in a back little building and tell me to keep, they gave me an oven, you can keep it out there. So I can't really recommend that you go and take a sample and put it in the oven to dry it and calculate, you know, your weight before and after, and oh, I've got 30% moisture. Some fellow said, well, you do that when you have neighbors coming over you don't like. So what we do is we recommend the squeeze test. So take a shovel, remove that outer layer, and remove some material from inside and pull it out, but it's hot. This is why you want to use a shovel. I have some rubber gloves in here if anybody wants to try it out here. You make a ball out of that material, but don't like squeeze it really hard. Okay, just make it so it sticks together. Set it on the top of the window and let it roll down the edge. If it breaks up about halfway down, that means that it's about 50% moisture, and that's where you want it to be. If it breaks up right at the top, you don't have enough moisture. And if you set the ball up there and it rolls all the way down and it's still sitting in a ball, you can probably bet you have too much moisture in there. So some others will recommend the squeeze test, squeeze it and see if you just have moisture in your hand or if water drips out. But I kind of like this, just roll the ball down the edge and see. So if you know it's too wet and you just really squeeze it lightly, you know, you're not going to get the response that you want.